this symbol here means to sum up. And we sum up whatever appears after the sigma. So we sum up whatever appears after the sigma notation. Okay, so I'm going to look at the official notation and I'll discuss in detail how this works. So the official notation looks something like this. So we are summing up n squared from n is equals to 1 to 4. So I'll just write this here for you. So this n squared is basically the formula for the nth term. Which means what we are basically getting the sum of. So what to sum? This one here is the term we start with. So this is the term we start with. This one here means the term we end with. So this is basically the meaning of this symbol, how we can write it, and what each part of the symbol means. Okay, I'm going to look at an example to discuss how to work this out. So this is a typical example that we'll get. Write the expression as a sum of terms. So what you're going to do is to use this expression to write the sum of the terms that you're given in this expression. So basically, I'll just copy this down. X from x is equals to 1 to 4 of x squared. So this is our nth term, and we can use that nth term to generate a series from x is equals to 1, so that will be 1 squared minus 3 plus 2 squared minus 3 plus 3 squared minus 3 plus 4 squared minus 3. And if we simplify that, we'll get minus 2 plus 1 plus 6 plus 13. So that is our series. And then in part B of the question, they're asking us to calculate the sum of these terms, and there are 4 terms. So sum of the 4 terms, we just add them up and get whatever we get. So in this case, it will be 18. Here is another example. Evaluate this expression. So what that means is we need to find the sum, because you're summing up whatever that comes after the sigma symbol. So the sum from a is equals to 3 to 8 of 2 to the power a will be 2 to the power 3 plus 2 to the power 4 plus 2 to the power 5 plus 2 to the power 6 plus 2 to the power 7 plus 2 to the power 8, which will be 8 plus 16 plus 32 plus 64 plus 128 plus 256. Now if you add all these up, they will be equal to 504. Here's another series. Write this series using sigma notation. So we need to inspect this series and find out if it's an arithmetic series or geometric series. Obviously, if you look through these terms, you can see that 15 from 3, that will be multiplied by 5. That multiplied by 5 as well, multiplied by 5, all the way. So this is a geometric series. Now, in this geometric series, the first term is 3, common ratio is 5, and therefore we can write the nth term, which will be, you know that the formula for nth term of a geometric series is u1 rn minus 1. So basically the nth term here will be, our first term is 3. So let me just write this. So our first term is 3 and our common ratio is 5 to the power n minus 1. Now remember, we are starting from, this series starts from when, from the first term, which is u1, to how many terms do we have in this series? 6 terms. u6. So from n is equals to 1 to n is equals to 6. So if I want to write a sigma notation for this, it will be from n is equals to 1 to 6, and then whatever I write after this symbol is just the nth term, which will be 3 into 5 to the power n minus 1. That's it. Here is another question. Find x if the sum of this series from k is equals to 1 to infinity is 4. Now, before we start working this out and trying to find out what's happening here, let's try and generate a few terms of this series and figure out if it's a geometric series and what is the first term, what's the common ratio, things like that. So, the sum from k is equals to 1 to infinity of 3x over 2 to power k minus 1 will be, now this series, the first term will be, we just plug 1 in place of k, so 3x over 2 to power 1 minus 1, which is 0, plus 3x over 2 to power k is equals to 2, so 2 minus 1, that will be 1, plus 3x over 2. When k is equals to 3, 3 minus 1 will be 2, and this goes all the way to infinity. I can simplify this, so anything to power 0 is 1, so 1 plus 3x over 2 plus 3x over 2 squared all the way to infinity. Now, by inspecting this series, now we are told, remember, that the sum of this series to infinity is equals to 4. And if you inspect the terms, the first 3 terms of that you are given here, you can actually notice that the common ratio, the first term is 1, and the common ratio is 3x over 2. And if the common ratio is 3x over 2, which means this is a geometric series, and the sum to infinity is 4, then it means that this geometric series is converging. So this is a geometric series that's converging, and we can write that as a converging geometric series. That's important because if it's a converging geometric series, we know how to find sum to infinity of a converging geometric series, u1 over 1 minus r. So basically what you're going to do is to plug whatever we have in that formula, equate it to 4, and solve for x. So what we'll have here is sum to infinity will be equal to, my first term is 1 minus my common ratio, which is 3x over 2, and this is equal to 4. We can swap these guys to end up with 1 is equal to actually 1 over 4. 1 over 4 is equals to 1 minus 3x over 2. And then you can swap these guys as well to end up with 3x over 2 is equals to 1 minus a quarter. And 1 minus a quarter is 3/4. So what we'll end up with here is 3x over 2 is equals to 3/4. If we multiply both sides by 2, we'll have 3x is equals to 3 over 2. And therefore x will be 3 over 2 divided by 3, which will be 3 over 6, which is a half. Therefore x is equals to a half.